One driver of the water availability is the climate change, of course, which we expect will decrease water availability in many regions, especially those relatively dry already today. But we should really focus on the demand side, actually, I think, do much more calculations on how much water is being used by individuals, by companies, by countries in the end, and for what purpose, and can we increase the efficiency for production of different goods, because a main driver really of water scarcity is the population growth per se, of course, but also the lifestyles, actually, especially the diet patterns and other products that we are consuming, because every product needs a specific amount of water, and if we what has started now really account for the water requirements for producing specific products, we get a broad overview on water consumption presently. This is done in so-called water footprint analysis, where you really can account for the amount of water used in every step of the production chain of every product that you can imagine. It's being done for, meat, it's been done for coffee and tea, for pizzas in the end, for T-shirts, for cars. There are such water footprint analysis going on.
Could you talk us through an example of one of those? Just so that
we have done within Watch and other projects, water footprint analysis for the globe, for the major crop products globally. And we found that, and we distinguished the internal footprints of countries, that is, how much water do countries use from their resources within the country territory, and how much water do they use from countries abroad, which are actually and this water is actually imported by importing agricultural goods from other countries. So we accounted for the fact that, let's say, country A imports tons of wheat from country B. We had a look at how much water has been consumed in the exporting country B for growing this wheat, and then we added this to the footprint of the importing country. So we know for every country how much water it uses from countries abroad and how much water it uses from its internal resources, actually. And this is the complete footprint then of a country, at least for these crop products. And we've seen that a lot of countries are main exporters of the so-called virtual water, like the US. They are a main exporter of products. Virtual water means that they don't export the water, of course, per se, but they export the other products which embed somehow the water that has been used in the production process. And we identified other countries that strongly rely on imports of agricultural goods, like many countries in the Near East, for example. They would just not have the water resources, and in some cases also not the land resources, to produce the food that they are consuming. So they depend on international trade of these goods. And we've also had a look into the future under specific scenarios of climate change and population change. And we've seen that really many more countries will become dependent on international trade of goods, because the water scarcity situation will increase in those countries, affecting many countries in Africa, for example, in Northern Africa in particular, due to climate change, which in some cases decreases water availability, but especially due to population growth. If you imagine that a country will have 20% more population in the future, and in addition it will see climate change effects decreasing the water availability, there are limits in countries in terms of the water availability for producing this food. So many countries do that already now in implicitly importing water from other countries, but we see the strong tendency that this will increase in the future, the country's dependency on international trade due to water limitations in their own country.